Let's take a look at the exercises for chapter 8, starting off with the multiple choice questions. For the first one, a simple random sample of 100 observations was taken from a large population. The sample mean and the standard deviation were determined to be 80 and 12 respectively. I'm looking for sigma x bar. Sigma x bar is equal to sigma over square root of n. Sigma is 12 divided by square root of 100. Therefore, the correct answer will be A. As the sample size increases, what's going to happen? So if you look at your formula, sigma over square root of n, if we increase the sample size, that means we're dividing with a larger number. Therefore, the standard error of the mean will decrease. So therefore, the correct answer is C. Random samples of a size 81 are taken from an infinite population whose mean and standard deviation are 218 respectively. The distribution of the population is unknown. The mean and the standard error of the mean are as follows. So I'm looking for mu x bar based on the main properties of the sampling distribution. Mu x bar is equal to mu equal to 200. Sigma x bar is equal to sigma over square root of n, and this is equal to 18 over square root of 81. Therefore, the correct answer will be D. The average age of cars in the US is 10.8 years. Assume that the standard deviation for this population is 3.5 years. A sample of 35 vehicles was selected. What is the probability that the sample mean will be greater than 10 years? So we are looking for x bar to be greater than 10. So normal distribution, mu x bar, same as the mu, 10.8. 10 is to the right, greater than 10. I'm looking for this whole area. We calculate the z-score. 10 minus 10.8 over 3.7 divided by square root of 35. This will be equal to 1.2792. We will round up to 1.28. 1.28 will give us a probability of 0.3997. This area is 0.5. All I need to do is add the 2, so the correct answer will be 0.8997. For number 5, from a population of 5,000 elements, a sample of 225 elements is selected. It is known that the variance of the population is 900. The standard error of the mean is. So sigma x bar is equal to sigma divided by square root of n. I have sigma x bar to be 900. From here, sigma will be equal to 30. You take the square root of 900. So 30 over square root of 225. This will be equal to 2, not 60. Therefore, this is false. Now, let's look at the problems. A large population of students spends an average of $10.50 a day on dinner. The standard deviation of the expenditure is $3.50 basically. A simple random sample of 49 students is taken. What are the expected value and standard deviation of the sample mean? Expected value is the same as the mean, same as the average, so I'm looking for mu x bar. Mu x bar is 1050. Sigma x bar is equal to sigma divided by square root of n, 3.5 over square root of 49, and this is equal to 0.5. What is the probability that the sample mean will be greater than 11.25? So we have Mu x bar equal to 10.5, 11.25 is to the right, greater than 11.25, I'm looking for a right tail. We calculate the z-score, 11.25 minus 1050 over 350 divided by square root of 49. Once again, make sure you use your parentheses, or you can simply use directly the standard error of the mean since you've already calculated on the first question. This will be equal to 1.5. 1.5 will give me a probability of 0.4332. Since I'm looking for a tail, this is going to be 0.5 minus 0.4332, and this will be equal to 0.0668. For the same problem, what is the probability that the sample mean will be between 10 and 1080? In this case, I'm looking for an area between two values where the mean is inside that area. We will look into finding the z-score for each value. 10 minus 10.5 over 3.5 divided by square root of 49. This is going to be -1. And then 10.8 minus 10.5 over 3.5 divided by a square root of 49. This is going to be equal to 0.6. We check the table for both z-scores. We take the absolute value for -1 and we check for 1.00. 1.00 will give us a probability of 0.3413 and 0.2257 for the rest of the area, for the corresponding area for a z-score for 10.8. The z-score for 10.8 is 0.6. 0.6 corresponds to the probability of 0.2257. Therefore, all we need to do is add the corresponding probabilities. So this will be equal to 0.3413 plus 0.2257, and this will be equal to 0.5670. The life expectancy in the US is 75 with a standard deviation of 8 years. A random sample of 100 individuals is selected. What is the probability that the sample mean will be greater than 76 years? The mean is 75, the standard deviation is 8, the sample size is 100, and we want to find the probability that X bar is greater than 76. So this is the area that I'm looking for. I'm looking for a left tail. If we calculate the z-score for 76, we will do 76 minus 75 over sigma, in this case is 8, divided by square root of 100. This is going to be 1.25. 1.25 corresponds to 0.3944. So 0.5 minus 0.3944, this is equal to 0.1056. So this area here is 0.1056. What is the probability that the sample mean will be less than 73 years? We calculate the z-score. This is the area we're looking for. We're going to calculate the z-score for 73. 73 minus 75 over 8 divided by square root of 100. The z-score will be negative 2.5. The corresponding probability for 2.5 is 0.4938. We're looking for a tail, 0.5 minus 0.4938. So this is equal to 0.0062. we calculate what is the probability that the sample mean will be greater than 72.5. Same problem, different question. So 72.5 is to the left of the mean. Greater than 72.5, we're looking for this whole area here that includes the 1/2. So this part is 0.5. Now to find this part of the area, I need to calculate the z-score first. So 72.5 minus 75 over sigma 8 divided by square root of 100. This will be equal to negative 3.13. This will give me a high probability of 0.4991. I add the 2, so this probability will be equal to 0.9991. The lengths of pregnancies are normally distributed with a mean of 280 days and a standard deviation of 20 days. If 100 women are randomly selected, find the probability that they have a mean pregnancy between 273 days and 286 days. So this is the area that I'm looking for. I will need to calculate the z-score for 273 and 286. Find the corresponding probabilities from the z-score, and then I will be adding the corresponding probabilities. So the z-score will be 273 minus 280 over 20 divided by square root of 100, and this is equal to negative 3.5. 286 minus 280 over 20 divided by square root of 100. So this will be equal to 3. By checking the table on the normal distribution, the probability should be, we have for 3.5, we have 0.4998. For a 3 is 0.4987. We add the two probabilities, so this will be, the answer will be equal to 0.9985. The body temperature of adults are normally distributed with a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.6 degrees Fahrenheit. If 25 adults are randomly selected, find the probability that the mean body temperature is less than 99 degrees Fahrenheit. So the mean is 98.6, standard deviation 0.6, n is equal to 25. This is the probability I'm looking for. This is the area based on what I have that I need to find. We start off by calculating the z-score for 99. 99 minus 98.6 over 0.6 divided by square root of 25. This is equal to 3.33, which means that this area is 0.4996. I already know this area to be 0.5, so this will be equal to 0.9996. Problem number 5. A coffee machine dispenses normally distributed amounts of coffee with a mean of 12 ounces and a standard deviation of 0.2 ounce. If a sample of 9 cups is selected, find the probability that the mean of the sample will be less than 12.1 ounces. So, based on what I have, I'm looking for this area less than 12.1, so it's the whole area to the left of 12.1. We find the z-score for 12.1. 12.1 minus 12 over sigma is, let's see what we have. Sigma is 0.2 divided by the square root of 9. This will be 1.5. 1.5 gives me a probability of 0.4332. This is 0.5. I add the corresponding probabilities, so the probability that I end up with will be 0.9332. Problem number 6. The average number of pounds of red meat a person consumes each year is 196. Sigma is equal to 22. N is equal to 50. Find the probability that the mean of the sample will be greater than 200 pounds. So you draw the normal curve. Mu x bar 196, the same as mu. 200 to the right, greater than 200. I'm looking for the area to the right of 200. That means I'm looking for a right tail. Next step, you calculate your z-score. Z-score will be equal to 200 minus 196 over 22 divided by square root of 50, and this will be equal to 1.29. 1.29 gives me a probability of 0.4015, and since I'm looking for a tail, this will be 0.5 minus 0.4015, which will be equal to 0.0985. And this concludes the exercises for Chapter 8.